Welcome back. In the second half, we'll go through a short example of how to use OpenSense and highlight other resources to help get started with OpenSense. And here's an outline for this half. We'll review quickly the IMU-based workflow or Inertial Measurement Unit-based workflow. We'll discuss some of the tools in OpenSense. We'll walk through a quick example, and then we'll highlight other helpful resources that can help you out with your own data. So let's start by reviewing the workflow real quickly from experimental data to joint angles using inertial measurement units. First data is collected by IMU devices, and some examples of companies that sell these are Xsense and APDM. Then the data are used in a sensor fusion step to estimate IMU orientations. Some of these algorithms are published, such as those by Madrick and colleagues and Mahoney and colleagues, and some algorithms have been developed by some companies to be used with their own IMUs, such as Xsense. At this point, this is where OpenSim provides tools to help estimate kinematics, starting with IMU orientations and going to joint angles. Two tools help in doing this. The first of which is the IMU Placer to create a model with IMUs with the correct orientation on each body. The second is the IMU IK tool, or Inverse Kinematics tool, which takes the model and orientation data from a motion to produce joint angles. And we'll take a closer look at each of these tools in a couple slides. But first, a quick reminder of what OpenSense is and how it works with our other software package, OpenSim. As we saw, OpenSense provides open source tools for estimating kinematics using IMU orientation data, along with a kinematic model to estimate joint angles. OpenSense is built on our open source musculoskeletal modeling package called OpenSim. And this allows us to use many existing OpenSim models and other components to help estimate joint angles. And it also makes it easier to take the joint angle results and help provide insight into other biomechanical quantities such as muscle lengths and velocities. So now let's go into detail about two of the major OpenSense tools. First is the IMU Placer tool, and it takes as inputs an OpenSim model and IMU calibration data. And it finds the initial orientations of the IMU frames or coordinate systems relative to the OpenSim model's body segments. This outputs a new OpenSim model that's updated with IMUs with the correct orientation on each body segment. So how does choosing these inputs look like in the GUI? On the right is the GUI toolbox provided in OpenSim, which helps the user choose inputs for the tool. This tool assumes a model has already been loaded, so I've listed that as step 0 here. So the model should be loaded into the GUI already. The first input into the IMU Placer tool is the orientation file or the orientation data at the pose that matches the model's pose. Second, we need space-fixed Euler angles, and these need to represent the rotation sequence to align the IMU frame to the OpenSim's ground frame. And finally, IMU placement or heading correction. This step ensures that a specific IMU's axis is pointing in the model's forward heading. This helps correct for cases where the participant wasn't facing forward in the ground frame. And together, all of this outputs a model that has IMUs oriented correctly on each body frame. The other major OpenSense tool is the IMU Inverse Kinematics tool. And this step takes as inputs an OpenSim model after the IMU Placer step and experimental orientation data. This finds the best fit for joint angles that match the orientation data at each time step of the input data. And this outputs a file with joint angle values at each time step from the data. Let's see how this step is done in the GUI. And like before, a model is assumed to be loaded in the GUI already. First, we need space-fixed Euler angles. And again, this is the rotation sequence to align the ground frames of the IMU space and the OpenSim space. And this should be the same as what was in the IMU Placer. Second is sensor orientation file, or the orientation data for the motion trial of interest. Third, you can optionally provide weights for each IMU to increase or decrease its influence on the solution. And finally, time range. So you can provide a start and end time to indicate which time steps to analyze. And the output of all this is a motion file that contains joint angle values for each time step analyzed in the specified time range. Now I'll highlight these two tools, the IMU Placer and IMU IK tools, by using a Gait example that we provide as an example with OpenSim. And the example will focus on the OpenSense box, starting with IMU orientations and a model. But where do these IMU orientations come from? And for this example, we collected IMU data using XSense devices. And sensor fusion was done using XSense's algorithm. So we actually import the orientations directly from the XSense setup. And the model we'll use is based on a popular OpenSim model from Rajagopal and colleagues. So we'll get into the example now. The files used here all come packaged with the standard download package of OpenSim and can be found in the models folder under the Rajagopal OpenSense subfolder. In this example, we'll use data from a Gait experiment to estimate joint angles during walking, and we'll get results similar to the ones seen here in this video. So with that, I'll switch over to OpenSim. I think you should be able to see it now. So here's OpenSim, and again, we're going to go through the IMU Placer step and the IMU IK step. So the first thing we need to do is load a model. So we'll go to File up here and open Model, the first row here. And we'll see I'm already in the correct folder here in the Rajagopal OpenSense subfolder. And I'll open the one OSIM model. So OSIM is our file type for an OpenSim model. So here's our model. And now that we've loaded that up, we'll go to the IMU Placer tool. So that's under Tools. And down here is IMU Placer. I'll go ahead and click that. Now we need an orientation file at the placement pose. So I will browse for this, hitting the folder icon to the right here. And we see that there is a placement orientations.sto file here. And I'll choose that. Next, I have to provide the space-fixed Euler angles from IMU space to OpenSim. And for our data, we knew that we had to rotate this minus 90 degrees in the X rotation. Finally, for IMU placement and heading, our setup had our torso IMU facing the forward heading of positive Z. And so I'll run this. Should run pretty fast. I'll close out of the toolbox. And here's our new model. You can see some of the IMUs here as these blocks. Cool. So the next step is to take this model and run inverse kinematics with it. So that's another tool. So I'll come back up here and click on Tools. And I will choose the IMU Inverse Kinematics tool. Again, the first thing we need are the space-fixed angles. And so that was minus 90 in the X direction. Again, we need to choose the trial that we want to analyze the motion. So actually just do that a little more slowly. I'll click on the folder icon over here to choose the file. And we provide a walking orientations file here. So we'll open that. I talked about how you can choose the weights. So if I click weights, you can see the different IMU names on the left, along with the weights on the right. If you double click into here, you can see you can change some of the weights. For this example, I'll just leave them at 1. And finally, we can choose the time range. So I'm going to make this a little shorter. I'll just go from 10 to 15 in the interest of time. And finally, we need to give an output name. I'll just give this as motion.sto. And STO stands for a storage file. That's our typical file for storing a bunch of different values, such as joint angles out of IK. So, and that's a typical OpenSim format. So now that's all there. I'll hit run, and we can see solving happening. You can see in the messages window that it's solving at each time frame, and you can see that it's visualizing the solution at each time frame on the right. And you can see we're getting a walking motion out of it. It is doing this a little slowly because I'm also running Zoom and everything at the same time. But there you go. So we're about to finish. And once it does, you can use a bunch of the same tools in OpenSim. You can replay the motion. You can also go to any time point in the motion. So I'll play the motion a little bit there. And there we go. So we went from, just as a recap, we went from a standard model, we added IMUs, and then we actually got a walking motion in the end with the data. So I'll switch back to slides now. And I'll go into some common questions that we see from OpenSense users about using OpenSense with their own data. And the first question is, which IMU devices are supported? We currently provide tools to import data from XSense and APDM IMUs through our C++, MATLAB, and Python APIs. And we're looking to expand these tools based on the needs of the community. You can also create your own custom import tools by looking at the format in the example files and matching that format by developing your own custom code in MATLAB, Python, or whatever languages you like. Second, how can you find the transform from IMU to OpenSim space for my data? This step can differ quite a bit depending on your setup, but here are a couple suggestions. First is to check if the documentation for your IMU system has some helpful information about the coordinate system it uses. For instance, our system used an east-north-up basis for its X, Y, and Z coordinate system. And we know that OpenSim's up direction is the y-axis. So we have to rotate about the x-axis to align the two up directions between the IMU space and OpenSim space. Another method that could help is to visualize the IMU data and compare how the axes look in OpenSim space. So how can you visualize raw IMU data? We can use the GUI to visualize the raw data, and we'll step through a short example here through the slides. This example also uses the same files that we just used in the GUI example. So the first step is to load a model of interest. And once the model is loaded, you can go to File and down to the Preview Sensor Data option, which will open a dialog box. And we'll select the file we used for the IMU Placer step, placerorientations.sto. This will open another box titled Sensor Data Options. First, looking at the rotate options, we won't indicate any rotations. And this is mimicking what could happen with new data where we don't know the correct transformation from IMU space to OpenSim space ahead of time. Under layout are a few options that will change where the IMUs show up in the GUI. Feel free to try these different options out, but for today, I'll highlight the use of the option that's called Place at Matching Segments on Current Model. So we'll select this option and then you can hit OK. And what you'll see now is that the model is updated with the IMU data on each body segment using the OpenSim color convention for the axes where X is red, Y is green, and Z is blue. Since a model with even a handful of IMUs will add many lines, you can reduce the number of lines shown by either hiding or showing each IMU by right-clicking the IMU in the navigator pane on the left, and this can be helpful to reduce clutter when analyzing the data. Finally, we'll touch on a few other OpenSense resources out there. Another example provided uses the MATLAB scripting, and directions are available on the OpenSim Confluence documentation website. The example covers some other functionality that we didn't go into detail here today, including importing data from an XSense setup and running the IMU Placer Tool and IMU IK tools using a setup file instead. As mentioned before, OpenSense tools are available through both our GUI as well as our APIs with C++, MATLAB, and Python. And a great place to get support is through our OpenSim forum, which we monitor and has experts from around the world active as well. You can find the forum by going to the OpenSim project page on SimTK at the link shown here and clicking forum along the top. Thanks so much again for listening about our work. Thanks to the team led by Mazen and Hannah that carried out the validation study. And finally, thank you to the NIH for funding the Restore and Mobilize centers that supported this work.
All right, thank you, Carmichael. Super clear, super interesting. We're going to switch back to more questions. I've also been trying to answer some of those by typing as well. So let's see. We'll dive right in so we can get to as many of these as we can. Let me see which are. Okay. Question from Tan Lehman. How do you figure out how to rotate the sensors to match the IMU frame with the ground frame using the space fixed angles?
Yeah, that's definitely a tricky step. We talked about a couple ideas of checking your documentation to see if they give any clues about how they set up their IMU ground frame. And hopefully some of the visualization tools in OpenSim can help you out with that too. Unfortunately, sometimes it might take a few attempts and a little bit of trial and error to get those aligned correctly.
Yeah, Tan also asked about how you ensure correct placement of the IMUs on the OpenSim model with the IMU Placer, because sometimes they're not placed correctly. And part of that too is visualization. A lot of users have reported similar issues. So, in the future, we could try to explore having better tools to help people iterate, identify sensor misplacement as well in that step. Okay, a question from Jack Martin. Do your import tools have an option to import joint angles determined by, for example, XSense, and then use these to determine muscle length in an OpenSim model?
Yeah, that's a good question. I would say, I don't know if we have any canned tools with OpenSim to do that, but similar to what we discussed before, if you look at one of those storage files that come out of Inverse Kinematics, you'll see it's actually just a tab delimited file. And so you can write your own scripts in MATLAB to get into the same format as that file, and then you can use that file as if they were results from IK to do other analyses and use other analyses in OpenSim. Yeah.
Iman is on the call too. At some point, I think you could provide some joint angles to track in IK, like if you didn't have the full set or had a mix, but maybe Iman, if he's listening, can confirm or refute that in the chat for us. Okay. Let's see, another question from Elena Cacconi. Does the same also, let me see. Okay, maybe this is a follow-up to some questions asked verbally about whether you can use OpenSense to study movement in infants and children. So the follow-on question, are all these models based on data from adults only? Would it be appropriate to make inferences about how muscles work in these models based on data from adults only? I think there's different layers to that question. We have used OpenSim models to study gait in children with cerebral palsy, for example. I think if you're looking at, you're just interested in joint angles and kinematics, and you may need, perhaps you do need to do a scaling in that case to look at kinematics. I think to, just to visualize your results, you would likely want to scale your model because the anthropometry of an adult is very different from a child. Sorry, I have young kids, and when I put my hands over my head, there's so much room, but my son, his hands only reach right here. Kids have big heads, and for example, anyways, so I think you would probably want to do that scaling. When you start to get into, infants, I don't know if anyone has created simulations of infants. And then you may also have differences and say how strong muscles are, the relative strengths of different muscles that might affect a muscle-driven simulation result. So kind of the tools and algorithms are there, but there may be more work needed on improving the musculoskeletal models, for example, if you want to do a muscle-driven simulation, and also to validate it against current approaches. Okay, hopefully that helped answer some of those questions. A question from Erkan Kaplanoglu. Is there a time delay between the IMU data? And if this delay is permanent, can we add it to the model?
I'm not sure exactly what time delay you may be referring to. I don't know if you had any more details to add, but in general, you kind of measure the data as is, and it will send it down. So we didn't have to deal with any delays on our end. But if there were any other details you had, feel free to mention what those could be. Yeah.
A question from Kristen Beach. Have you looked into any signal pre-processing steps, for example, for magnetic distortion detection that could potentially improve performance? Or were there any other signal processing steps that might help?
That's a really good question. I'd probably look at the paper's methods just to double check. I'm having trouble remembering exactly all the steps off the top of my head. These are good points. These are noisy, just like any other reading. So I think it would be valuable to look into pre-processing steps, filtering, things like that. With some of the sensor fusion algorithms out there, there are some knobs that you can turn, especially related to the magnetic distortion, that allows you to kind of consider the magnetic distortion either at like a faster or slower rate. And we did see that affected some of our results as well. So there's, especially with some of these more open sensor fusion algorithms, definitely take a look at them and check out all the knobs that they have, because that could definitely help with the magnetic distortion, especially when you use it in a lab.
Okay. Now we have a question from Jack Martin. Do you have any comments on OpenSense IK versus, for example, XSense IK? Are there situations where one will be more reliable than the other? I think this one is hard to answer because we didn't, like Carmichael mentioned earlier, we didn't compare directly to the XSense IK results to be able to say that. I think that, from what I've seen, XSense works quite well, and we're not intending, we're not intending to replace XSense, but complement it, for example, when you have different types of subjects that you want to study, when, you want a little more detail about what's going on inside the algorithms. So yeah, that would be interesting to see and have a better handle on if there are cases where one works better than the other. Okay, let's see. We have time for a few more questions. We answered that one. Okay, a question from Tyler Rooks. How sensitive are the OpenSense estimates? So we talked a little bit about sensitivity to positioning and placement. But the second part of the question, have you encountered problems with any particular locations of the IMUs?
We haven't done a detailed study of exactly where on, like the upper leg you might want to put an IMU. I feel like I've seen some in literature that are looking at that and where some placements may or may not be more or less sensitive. So I don't want to say too much on that end. I'd say definitely check out the literature. There should be some good work out there that are really looking at these really important questions, and absolutely the placements matter, and as a field, learning which placements matter more or less will be super helpful as we move out of the lab into rehab applications where we really want as few IMUs as possible.
Great. A question from Sarah Alnahas. Can we use OpenSense to estimate foot clearance or displacement over an obstacle during walking?
Yeah, that's interesting, since how high your foot is off the ground when you only know orientations of bodies really tells you how, so rather your joint angles are what tell you how far your foot is off the ground. So getting those joint angles correct is really important. I'd imagine that might be a little tricky, especially I'd imagine if you're trying to study foot clearance, you care about, things on the millimeter or centimeter level. So you would definitely want to validate that work and see how well
I think this is a
work.
case where you would need to scale your model as
That
well.
too.
If you wanted to get foot clearance. And you'd also want to, have a way to know whether the opposite foot's in contact with the ground and kind of lock it there. So I think in theory, it's something you can do, not designed to look at it right now. You have to do some more development, I think, and testing, like Carmichael said. All right. A question from Hans Hugo. Can you use OpenSim to estimate ground reaction forces?
So I'm going to assume this means from IMU data. So there are methods out there to estimate ground reaction forces. We didn't touch on this, but OpenSim also has a package called MoCo where we use direct collocation methods to estimate movement from various data. One of which that we just added was, can you do it from accelerometers and gyro from IMUs? And since you get a full simulation with ground contact from MoCo, it's possible that that could work. And we're just starting to scratch the surface on that. Other groups have also used direct collocation methods already with IMU data. And so there's good literature out there that you can actually estimate ground reaction forces pretty well from IMU-based data.
Okay. Next, we have a question from, that one's done. Jasper Johns, did you come across any difficulties with artifacts? And I think this will be the last question we'll have to take since we're at 11. With artifacts in the XSense raw sensor data, we currently have a problem with some dropped frames in the exported sensor orientation that lead to large spikes in the OpenSim joint angles.
Yeah, I think, I'm trying to remember how many trials we considered good and not good. And definitely if you see big errors, we kind of had to reject those trials as well. So I'd say we definitely saw some issues, but for the most part, we got pretty good results using the XSense data. And by raw data, I'm assuming you mean the accelerator and gyro. And in the paper, you can see that we use those with some of the open source sensor fusion algorithms like Madrick and Mahoney to get some of our better results in the paper.
Okay, so I apologize, we weren't able to get to everyone's questions. We'll try to follow up with some of these after the webinar, or encourage you to hop on our user forum as well, where we can answer more questions there. We'll go ahead and wrap up. Thank you again to Carmichael for the great talk, and everyone for all the great questions. Please be sure to click on the link that will appear at the conclusion of the webinar to take our survey. That'll help us improve the webinar series and choose upcoming topics for the webinar. And again, want to acknowledge the webinar series is supported by 2 grants from the NIH, including the grants that support our Mobilize Center and Restore Center. We're grateful to the support that allows us to run these webinars and other events. So thank you again to everyone for participating. We hope you'll continue to stay involved with our centers, and that we'll see you at a future webinar. Bye, everyone.